बॅच सोडून द्या. बसतो आता एक तरी 15 मिनिट गेले. Good morning, friends. Am I audible to you? Good morning. I said good morning. Ritesh.
Good morning, ma'am.
Yeah. Prasad Bhosle, what is your roll number? Prasad Bhosle. Prasad Bhosle.
Ma'am, 46.
Yeah, please write it down. Just another 1 minute. We'll wait for.
मैम
हाँ बोलो.
मकर संक्रांति मैम.
Yeah, happy Sankrant to all. Good morning, everyone. Stay safe.
Good morning, ma'am.
Yeah, stay safe, stay home. If required, then only move out. Listen to your parents. It is for your benefit because the number of cases are increasing. Take utmost care. We want to see you soon to the college. Now, since the cases are increasing from today onward, we will be working from home. We are not, up to yesterday, we were going to the college alternate day. But now from today onward, we are allowed to take the classes from home. So you also take care of yourself and your family members. Okay, we'll start what we have studied last week, last lecture. We have studied, if you remember, yes, ion exchange method, cation exchange method for which RH2 is used, and an exchange method for which ROH twice is used. Do you remember the reaction with the cation exchange resin? Yes, anyone? Chalo pataphat. Chalo cation exchange resin. CaCl2, yes, giving you
CaCl2 gives Ca2 plus 2Cl minus.
correct. Next reaction,
Ca2 plus RH2 gives RCa plus 2H plus.
yeah. Next, with
2H plus and the first reaction of 2Cl minus combine and produce 2HCl.
good. Now anion exchange resin,
MgSO4.
anion exchange resin, twice HCl plus ROH twice, yes, gives you RCl2 plus twice H2O. And that H2O goes to the third container, which is a degasifier, which removes the dissolved gases which are harmful. Which gases are harmful? H2S, SO2, they are mainly very much harmful. Also the halogens, if they goes to the water sample, H2S, SO2, NH3, PO4, salts, etc., they are very much harmful. The dissolved gases H2S, SO2 they are removed by heating it electrically. Then we have seen the differences, only two differences. Chalo, someone speak out, someone else. I want two differences between zeolite and ion exchange.
Yes, ma'am.
Bolo.
Ma'am, softener use is in the process is crystal और ion exchanger में मैम वो ion exchange resin है.
Okay. Here zeolite is
Or-
used as a softener. There ion exchange resins are used. One difference is over. Second, फटाफट
We
आप
cannot use acid and alkaline because zeolite gets dissolved in it, but iron cannot. I mean, we can use ion exchange method.
Okay, so that is there. These are the differences. Few more I will take fatafat. Zeolite is compact instrument, so softening process is possible anywhere, everywhere. Ion exchange is not a compact one, so it is possible only one at the place of installation. Zeolite reduces the hardness to 5 to 10 ppm, whereas ion exchange reduces the hardness to 2 ppm. Zeolite doesn't remove the dissolved gases. Ion exchange removes the dissolved gases. So these are the few examples of this. Now the water obtained from the zeolite contain excess of sodium ion, so it is not fit for steam generation in the boiler. It causes casting embrittlement. I explained it that due to NaOH form at high temperature, or obviously in the boiler temperature is high because of the steam formation. So due to high temperature, the boiler parts become brittle. They come to the stage of breaking, especially the boiler parts which are present. अरे कोणाकडे काय फुटलं रे बाळांनो? हा माईक म्यूट करा ना. असं नाही, आज काही व्हायला नाही पाहिजे कोणाकडेच, ऍक्सिडेंटने पण नाही व्हायला पाहिजे. चला, जस्ट जोकिंग, डोंट टेक इट अदरवाइज. कोणाचं माईक चालू आहे बेटा? कोणाचं माईक चालू आहे? आर्यन, आर्यन बेटा, माईक म्यूट करो प्लीज. काइंड रिक्वेस्ट.
मॅम,
हा बोलो.
जिओलाइट प्रोसेस मध्ये प्रेसिपिटेशन होत नाही, ती क्लीन प्रोसेस आहे ना?
क्लीन प्रोसेस आहे आणि
आणि
त्याला स्किल्ड वर्कर लागत नाही. इथे पण स्किल्ड वर्कर थोड्याफार प्रमाणात लागतात, कारण ते वेळेतून एका कंटेनर मधनं दुसऱ्या कंटेनर मध्ये आणि एक्सचेंज रिएक्शन. जिओलाइट मध्ये ब्राईन सोल्युशन वापरतात रिजनरेशन करता, आणि आयन एक्सचेंज मध्ये HCl, H2SO4, HNO3 किंवा फॉर ऍसिड RH2 जनरेशन आणि ROH ट्वाइस जनरेशन करता आपण NOH, KOH वापरतो. So that is there. The maintenance cost is low for the ion exchange, but investment is high because that and costly chemicals are required there. So that is little bit costlier, but even then you can use that water. It is used for acidic and alkaline water. It is suitable. Only for turbid water it is not suitable. That is common for zeolite and ion exchange. Now we will go further for the next, the desalination method. In the notes, this is not mentioned anywhere, but write down desalination method. Desalination methods means you have to remove the salt from the water, and mainly you know that the salt is present in the seawater. So these two methods are used for the desalination method. The question may be there, what are the two desalination method? So one is reverse osmosis and second is electrodialysis. Now basically these methods are invented for removing the salt from the seawater, but nowadays you know that reverse osmosis, it is used in the domestic purpose also, for the filtration purpose. You might be having the filter at home which works on the principle of reverse osmosis. So that is there. Mainly initially they are suggested for the removal of salt from the water sample, and therefore they are called as desalination methods. The two desalination methods are reverse osmosis and electrodialysis. Very simple to understand. We will see, that is the next lecture we have, which we have to finish it today. So as I have told you, these are the slides which are made by our HOD, because everyone has made the notes for one PPT for one chapter. So we have to study the softening method. Now there is a difference between softening and purification. Pay attention. Today what we are studying, today or earlier what we have studied, these are the softening method. Zeolite, ion exchange, reverse osmosis, and actually reverse osmosis and electrodialysis, these are done for the purification of water, not softening of water. When the water is to be used for domestic purpose, it is purification. And when the water is to be used for the industrial purpose, it is softening. So zeolite and ion exchange, they are basically softening processes, reverse osmosis and electrodialysis, as well as whatever the processes are carried out by the corporation, because of which we are likely to get the pure water. They are called as the purification method, that is bleaching, sterilization, etc. etc. So that are also purification म्हणजे घरात वापरायचं पाणी जे आहे, ड्रिंकिंग करता, कुकिंग करता, बेथिंग करता, वॉशिंग करता, ह्याच्या करता जे पाणी वापरायचंय त्याकरता जी पाण्याची ट्रीटमेंट दिली जाते त्याला प्युरिफिकेशन म्हणायचं. आणि इंडस्ट्रीकडे जर आपल्याला पाणी वापरायचं असेल तर त्याला सॉफ्टनिंग प्रोसेस म्हणायचं. So here that is there. Then this is the osmosis. Now here it is a semi-permeable membrane. Semi-permeable membrane which allows the flow only in one directional. That is why it is called as semi-permeable membrane. Two-way flow is not observed. So in case of osmosis, this is a cell. Usually it is made up of glass. There is a salt breach or there may be a semi-permeable membrane. And if you you will observe, here the impurities are more, here the impurities are less. So under normal condition, the tendency is that the pure water will move to the higher concentration of impurity. Here the concentration of impurity is more, concentration of impurity is less. So under normal condition, water flows from, the water is a solvent here. It flows from lower concentration to the higher concentration in when the two solutions of different concentration are separated by semi-permeable membrane. And this particular process is called as osmosis. I'll repeat. The solvent moves from lower concentration to the higher concentration when two different concentrated solution are separated by semi-permeable membrane. Here the concentration of impurity is more, here the concentration of impurity is less. That is why they have different concentration. So when two different concentrated solution are separated by semi-permeable membrane, always solvent will move from lower concentration to higher concentration under the normal condition, that is called as osmosis. But if you apply some pressure here, which is little above the osmotic pressure, for example 200 psi, etc., then the flow of water is in the reverse direction. It will move from more concentration to the lower concentration, and that is called as reverse osmosis. So whatever the filters we have at home, it works on the principle of reverse osmosis. So certain pressure is applied on the side of higher concentrated solution, higher concentration of impurity, which is about of the order of 200 psi. Then the flow, the direction of flow of solvent is reverse. That is, it will flow from higher concentration to the lower, and thus the pure water is separated from the impurity. And this principle is called as reverse osmosis. So when two different concentrated solution are separated by semi-permeable membrane, if the pressure is applied, which is little bit more than osmotic pressure on the higher concentrated side, then there is a flow of water from higher concentration to the lower concentration, and this particular phenomenon is called as the reverse osmosis. So here water gets separated from the impurity. In earlier case in the osmosis, water, pure water moves to the impurity without any pressure, and here water moves from higher impurity to the lower impurity, and thus the softening takes place. This is the principle used in our filters which we use at home. So here we can take the sea water, river water, lake water, etc. Basically it was suggested for the sea water, therefore it is called as desalination method, removal of salt from this. Here we have to apply 200 psi pressure on the side where we have higher concentration of impurity. Now the membrane here should have proper porosity. Porosity, if it is bigger, then maybe impurities also will travel along with the pure water. So porosity should not be the pore size should not be bigger. The diameter of the pores should not be bigger. It should be limited so that it will restrict the flow of the impurity. And for that purpose, these are made up of, remember these three example, SPM, they are made up of acrylic material, polyamide or aramide. Remember, acrylic material, polyamide or aramide. Acrylic material, polyamide, aramide. For acrylic material, why I am repeating this? Because it is important. So we should have the SPM of appropriate porosity so that it will not allow the impurity to pass through it. And for that purpose, it should be acrylic, polyamide or aramide. Acrylic, polyamide or aramide. Acrylic, polyamide or aramide. So that's the three material recommended for SPM. So acrylic, polyamide and aramide. That is the method of electrodialysis. So you have to take a cell, you have to place the sea water or salt water, you have to place the SPM of appropriate porosity, which is made up of maybe acrylic, polyamide or aramide, and then apply the pressure of 200 psi at the side of where the concentration of impurity is more. Under that pressure, the water will flow from the higher concentration to the lower and thus get separated, which is useful for the purification, which is useful for drinking, washing, cleaning, bathing, cooking, etc. So that is the purification method. Here we are removing the salts here. That is why it is called as desalination method. But in our regular water, the salt may not be there. In seawater, 3.4% salt is there by weight percentage of this, and that is why this method is desalination. But in the water which is there from the bore well, etc., the percentage of the salt is less, but along with that it also removes some other suspended impurities, etc. So it is commonly used there. Now what happens, the other part is not given in this PPT. So once all the pores get filled in by the impurities, salt, etc., then you have to remove that SPM and you have to regenerate it. So you have to regenerate it by suitable method. Either you have to dry it, you have to wash it with hot water. So all the pores will get impurities from the pores get removed, and then you have to dry it for 2-3 days in a very hot under the influence of hot sun. That particular part is not given in this. So remember this complete process, because whatever the process is given, it is the half process. So after the pores get filled, then there will not be infiltration or transfer of water from higher impurity to lower impurity unless and until it is regenerated. So SPM is removed. It is washed with the hot water to make the pores free from the impurity, and it is dried under the influence of hot sun, maybe for a couple of days, 2, 3, 4 days, etc., which will remove everything, and then SPM is used again. So that is the half part which is not given here. Remember that it is required. Now second method is electrodialysis. Here also it is a second desalination method. Basically it was suggested for removing the salt from the water. Basically it was suggested for removing the salt from the water, but here we have to use the electricity. So it removes the ionic pollutants, so like salts, ionic dyes, etc. If they are coloring pigments, if they are there, they are removed by this method by using the semi-permeable membrane as well as electric field. That is why it is called as electrodialysis. Now it is in this case, first I will show the explain this. This is a huge container, and these are the CEM is cation selective membrane, and AEM is anion selective membrane. Uh, uh, so we have the number of alternately placed cation selective and anion selective membrane in a huge tank. Usually it is metallic, sometimes it is made up of glass. They are alternately placed in a container, At one end there is a anode, at another end there is a cathode, and when the electric current is passed through it, then the suppose salt is there, NaCl salt, you know the formula, NaCl. So cation moves to the cathode under the influence of electric field, and anion moves to the anode, and thus the when you remove the electrode, the water is free from the both cation and anion, that is salt, and this method is called as desalination method or electrodialysis. Earlier method, uh, we have seen that there was a mechanism of SPM, only high pressure you have to apply it at high impurity size. Here it is different, pressure is of no question. Here we have to apply the electric current and semi-permeable membrane. So this semi-permeable membrane are cation selective membrane and anion selective membrane. There you can see cation selective membrane is there, anion selective membrane, cation selective membrane, anion selective membrane, cation selective membrane, anion selective membrane, cation selective membrane. Here there is a anode, here there is a cathode. So cation is, who is the cation? NaCl. Imagine that NaCl ionized as a Na plus and Cl minus. So who is the cation there? Na plus
Na
or Cl?
plus.
Na plus is cation, it will move to the cathode, and Cl minus is anion, which moves to the anode. So remember, cation towards cathode, anion towards anode, under the influence of electric field. So what happens, suppose the water, see water is introduced here in the container, then immediately on passing the electric current, it is observed that Na plus will start moving to the so in this part, if NaCl is there, Na will go to this compartment, and in this part Cl will come to this compartment. So Na will come from this compartment to here, and Cl will come from this compartment to here. Na of this compartment will go to here. Just imagine, understand, लक्षात घ्या, इथे Na प्लस आलेला, इथे Cl मायनस, म्हणजे या कंपार्टमेंट मध्ये तुम्हाला परत सॉल्ट वॉटर मिळतं. आता या कंपार्टमेंट मधलं Cl मायनस इकडे ट्रान्सफर झालंय आणि Na प्लस इकडे गेले कॅटायन कडे. त्यामुळे हे जे कंपार्टमेंट आहे याच्यात वॉटर जे असेल, इट इज फ्री फ्रॉम द सॉल्ट. आर यू गेटिंग मी, और एम आय गोइंग लिटिल फास्ट? Speed is okay? Is the
Yes, ma'am.
Okay, so alternately, you get the compartment in which salt water will be there. Alternate compartment you will get where salt-free water will be there. Again, I'll explain an application of electric current under the influence of electric field. The Na plus will move to the cathode. Cl minus will try to move to the anode. In that case, Cl minus is coming to the anode. Na plus is moving to the cathode. So Na plus and Cl minus will be there in this compartment. So water will be rich in the Na plus and Cl minus concentration. So it is a salt rich water in this compartment. So, but what happens to the water in this compartment? Cl has moved to this compartment, Na has moved to this compartment. So in this compartment, you will find the pure water is there. Now what happens here? Na plus is moving to this compartment and Cl minus is coming to this. So again in this compartment, you will find that the pure water here salt rich water will be there. Again here salt free will be there, salt rich, and in this way we have the different compartment in the container for which we will have. Now how to take out? So for that, this is the final diagram. So this is the cation selective membrane, anion selective membrane, cation selective, anion selective, cation selective, anion selective. Here it is a anode, here it is a cathode. So you introduce the sea water, then cation will move here, anion will move here, and the water free from the cation and anion will be taken out from the exit here. That will give the pure water. Now what happens? Cl minus goes here, Na plus come here. So it will have salt rich water which is taken from this exit to this. So salt concentrated water is taken out by the separate exit. Again here you will have cation rich and anion rich water. So it is free from that. So it will be taken out as the pure water. Here again you will have the anion here, cation here. So it is salt rich water which is taken out from this exit. Two different colors are used for that. Blue color is for pure water, and this orange color is, or yellow or orange color is for the salt rich water. Again here we have the in this case the Na plus is coming here, Cl minus is going there, so it is pure water which is taken out through this exit. And in this way water is made free from the cation and anionic impurity. It is explained especially for the seawater. That is why it is called as desalination method. So what is the principle here? By using SPM and the electric field, we can remove the cationic as well as anionic part of the salt from the water, and that is the principle here. This is the whole method is there, which I have explained with the help of these two diagram. Have you understood? Yes.
Yes, ma'am.
Okay.
Yes, ma'am.
So actually how it looks like in the industry, that unit, electrodialysis unit, how it looks like. So this is the correct picture for the industrial setup. This is the correct picture for the industrial setup. This is salt rich, salt free, salt free, salt rich, salt free, salt rich, and salt free, which is taken out through this clear pipe, and which is taken out through this pipe. This is your cation, this is your anion, and this is the experimental. So you, in the descriptive examination, if the diagram is asked, because we will have subjective, earlier last year completely we had only the uh, objective multiple choice questions were there. Now we are planning to have, means for ACTV, what they have given the examination, it was subjective type. So this type maybe you will be asked to draw the diagram for reverse osmosis, or you may be asked to draw the diagram for electrodialysis, etc. Maybe that depends on the corona situation, or maybe principle is asked out of the two, what is reverse osmosis, principle for reverse osmosis, or principle for electrodialysis. So I'll repeat, principle for reverse osmosis is by applying higher pressure to the side of higher concentration of impurity when the two solutions are separated by semi-permeable membrane, then under the pressure of 200 psi, which is above the osmotic pressure of water, the pure solvent moves from higher impurity to the lower impurity, that is impures, that is reverse osmosis. But what is electrodialysis? By using the electric field and semi-permeable membrane, salt can be removed from the water. And this is the construction. Now again, semi-permeable membrane, aramid, polyamide, acrylic materials, and they should have appropriate porosity. Porosity is very much important for them. So how the water, this is how to explain the mechanism, and this is the industrial unit which is worked there. Now application here. What are the application of the electrodialysis? Removal of ionic pollutants like ionic dyes, toxic salts, etc. We have demonstrated with NaCl. Maybe if in, any other salts are there, they are removed in the same way. Earlier it was proposed for desalination method, therefore we have demonstrated it for NaCl. But any salt which dissociates, it is a strong salt which dissociates as cation and anion, that is removed by this method by using semi-permeable membrane and electric field. And it is mainly used, this method is also used for the industrial waste, to remove the industrial waste. इंडस्ट्रीतनं जे पाणी बाहेर पडतं त्याच्यात वेगवेगळ्या इम्प्युरिटीज असतात, काही कलर्ड इम्प्युरिटीज असतात, काही टॉक्सिक सॉल्ट्स असतात. तर मेनली रिव्हर्स ऑस्मॉसिस डोमेस्टिक पर्पज करता आपण वापरतो, आणि इलेक्ट्रोडायलिसिस, ॲज आय हॅव टोल्ड यू, दिस इज द instrument used by the this is the instrument used by the industry. इंडस्ट्रीतनं बाहेर पडलेलं पाणी जे टॉक्सिक पाणी असतं, तर ते बिफोर using it for maybe gardening purpose or other purposes. Maybe it can be used for the washroom purpose, that is toilet cleaning, etc. etc. शरीराशी ज्याचा संबंध येणार नाही, पण आपण गार्डनिंग मध्ये ते प्युअर करून वापरू शकतो. आपण ते बऱ्याच ठिकाणी पाणी तर त्याच्याकरता इलेक्ट्रोडायलिसिस सेटअप जर आपण इंडस्ट्रीच्या एक्झिट पाशी लावले आणि त्याच्यातनं पाणी फ्लो केले तर येणारं पाणी आपल्याला आहे. तर कोणाला जर इंटरेस्ट असेल आता करोनाच्या सिच्युएशन मध्ये गेटिंग द जॉब मे बी लिटिल डिफिकल्ट, or even if you will get, I'm not saying anything negative, but I'm guiding you to get it done positively, how it can be done in positively. So you can start the startup that you will ask for the fund, ask the company and take the charge that you will purify the water coming out of the industry, install this and take the complete knowledge, operation knowledge, without which you may not be able to operate it, and give the industry pure water which can be circulated, maybe can be used to certain extent without any risk for gardening purpose, etc. etc. Toilet cleaning, washing clothing फक्त पिण्याकरता किंवा कुकिंग करता वापरायचं नाही, because we are not sure, and there are some very labs. So along with this unit you have to set the labs also to find out what are the impurities retained in the water, and then accordingly you can suggest the use for of the water which is thrown out by the industry after the treatment, and you can do it. So removal of salt from the seawater to get the pure water, as I have told you, and removal of limited quantity of salts from seawater to get drinking water. तर त्याचे टेस्ट करायला लागेल BIS आणि WHO चे जे नॉर्म्स आहेत त्याच्यामध्ये ते फिट होते का, आणि जर इंडस्ट्रीतलं वॉटर आपण असंच वेस्ट न करता जर वापरलं आणि आपण जर सक्सेसफुल झालो तर दॅट इज नथिंग लाईक दॅट. आपण स्टार्टअप याच्यावर तुम्ही लिहू शकता, आणि याच्याकरता नॉट नेसेसरी की तुम्ही डिग्री घेतल्यावरच चालू करतात. आता सुद्धा सायमल्टेनियसली यू हॅव अ सफिशियंट टाइम, बिकॉज द क्लासेस आर ऑनलाईन. कॉलेजमध्ये जाणं येणं हा वेळ तुमचा वाचतो आहे, दुपारी सफिशियंट टाइम तुम्हाला मिळतो आहे, तर त्याचा युटिलाइज करून घ्या. असं काहीतरी माइंड करा, रिसर्च माइंड. नाही तर आपल्याला 19 महिने लागले करोनाच्या वर वॅक्सिन तयार करायला. तर अशा प्रकारचे जर पुढे संकट आले, याच्यापेक्षा भीषण संकट आले, तर ही जर रिसर्च माइंड तुम्ही आतापासून डेव्हलप केली तर it will be very much useful for you. So now next lecture we have to study municipal water treatment. And these are the textbooks, these are the reference books. So have you understood both the methods, application, its principle, etc.? Yes?
Ma'am.
Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes. Now we will start the next lecture. Whatever we will be able to, we'll try to cover. This is general knowledge. Only you need to learn the reactions. जनरल नॉलेज हे लेक्चर आहे, ज्याच्यामध्ये तुम्हाला माहिती आहे की तुरटी फिरवतात, त्याच्यानंतर सोडियम अल्युमिनेट फिरवतात पाण्यामधनं आणि त्याच्यातनं सस्पेंडेड इम्प्युरिटीज आपण बाहेर काढतो. डिझॉल्ड इम्प्युरिटीज पण आपण बॉइलिंग वगैरे करून स्टरलाइज करून त्याच्यातनं काढू शकतो आणि मग पाणी आपण ड्रिंकिंग पर्पज करता वापरू शकतो. तर म्युनिसिपल वॉटर ट्रीटमेंट इज mainly for the water to be used for the domestic purposes. तर कॉमन मेथड्स जे आहेत ते स्टरलायझेशन आहे, तुरटी फिरवणं आहे. मग त्याच्यात काही सस्पेंडेड इम्प्युरिटीज असतात, काही कोलायडल इम्प्युरिटीज असतात. तर सस्पेंडेड इम्प्युरिटीज कशा रिमूव्ह करायच्या? सस्पेंडेड इम्प्युरिटीज म्हणजे झाडाची पानं वगैरे वगैरे ज्या काय फ्लोट होत असतील पाण्यामध्ये, त्याला सस्पेंडेड इम्प्युरिटीज म्हणतात. सो यू अलाव द वॉटर टू स्टे अनडिस्टर्ब for a period, maybe from few hours to several hours, depending on the amount of suspended impurities. So if you keep the water undisturbed, slowly and steadily the suspended impurity will settle down at the bottom, and then you can remove the upper water, that is called as sedimentation. Now coagulation. What is unlike sedimentation, what is coagulation is we have the colloidal particles. Unlike suspended particle, colloidal particles carry some charge on them. For example, mud. All of them are negatively charged. जर पाण्यामध्ये mud असेल तर ते easily हे होत नाही. So this day, not these days, rainy season, you might have observed at your place, your mom, dad, they are using the alum. Alum म्हणजे तुरटी. तर ते फिरवतात. तर what is the role of that alum? That will remove the charges on the colloidal particle. Once the charges are removed, the impurities will become neutral, and then you have to carry out sedimentation. म्हणजे आधी colloidal impurities असेल तर you have to use the suitable coagulant. Alum is a coagulant. What is the role of coagulant? To remove the charges on the colloidal particle. Once the charges are removed, they will become neutral and they will settle down at the bottom, and then you can remove this precipitate by filtration, and then your pure water is ready. So sedimentation, coagulation is there. After that, the next method is the boiling and filtration. तर आता suspended impurities we have removed, colloidal impurities we have removed. Why the boiling is required? Boiling is required to remove the further trace amount of impurities. No doubt we are going to study the reactions also, but I am giving the initial knowledge so that mucking up the hitting the reaction is only your part. So after that, boiling and filtration. So why boiling is necessary? So if further trace amount of impurities are there, they are removed by boiling and filtration, and thus water is made free, which is circulated by municipal corporation for drinking purpose. So that is the total method used by this. But there are certain methods for removing the colloidal impurities, etc., etc. We'll see that. So this is there to study the municipal or domestic wastewater treatment. For everyone, learning outcome is we have to analyze the hardness, explain the methodologies involved in the water softening. Softening is for industrial purposes and purification is for domestic purposes. So that is there. Now these are the qualities. Remember at least 4 of them. Any 4 of them may be subjective type of question. You need to write this. What are the qualities of drinking or potable water? I leave it to you. It should be clear, odorless, pleasant in taste. It should be perfectly cool. It should be cool. Then it should not have turbidity more than 10 ppm. Otherwise, it is objectionable. It should not have dissolved gases like H2S, SO2, etc., which are harmful. It should be free from objectionable minerals such as lead, arsenic, etc. These are poisonous one. Lead, arsenic, chromium, manganese salts. These are poisonous one. Remember the example: lead, arsenic, chromium, manganese salt. Lead, arsenic, chromium, manganese salt. Lead, arsenic, chromium, manganese salts. These are poisonous ones. So turbidity should not be more than 10 ppm. Dissolved gases like H2S, SO2 should not be more than 500. Should not be more than a certain extent. Objectionable, it should be free from these gases. Then it should be clear, it should be perfectly cool, it should have a specific taste, it should be odorless and colorless. That is no specific color as that. It should not be, the alkalinity should not be above 8. Neutral water, you know that the pH is 7. So as long as possible, you can drink the water of pH 7 to 7.5, but never above 8 or below 7. So that is the pH range, desirable pH range for the water to be used for drinking purpose, 7 to 7.5 pH. It should be soft, means it should not have calcium and magnesium impurities in it, and that hardness should not be, here it is given wrongly, the hardness should be less than 150 ppm. Then only you can use it. If hardness is more, for example, calcium salts are there. If you keep on drinking such water, this calcium impurities get accumulated in the kidney or bladder, and it results in the formation of kidney stone or bladder stone. If the water is alkaline and if these calcium salts are there, because of which the water is hard, So here 500 is a wrong figure. It should be 150 ppm for drinkable. It is acceptable range is 150 ppm. Hardness should not exceed 150 ppm. 500 is galat. So that is there. Otherwise, it leads to the formation of kidney stone or bladder stone, and that is a problem with many of this. Now you might have seen the articles or the journal that even this Bisleri type of water, I'm not saying Bisleri company water, but this mineral water which is available commercially, it is not 100% useful for drinking purpose. It still has the hardness more than the acceptable range, and therefore even if you drink it, the person says that I have a kidney stone problem, I will drink only the mineral water when I am not at home, when I will be moving for some work. So that is also not correct, because there are certain brands, it is observed that the plain water which is there only by boiling and filtration, they are packing in the bottle and they are selling it. They are not carrying out any treatment, and that is not good. So you can also do it, but don't do it for this, because earning money should not be our aim. We have to earn the money through a proper channel with a proper method. So that is there, and it should be free from the microorganisms which may have, or the biological impurities, microorganism or biological impurities which are the disease causing microorganism. एखादं पाणी प्यायलं पावसाळ्यात आपण, तर मग आपल्याला कुठले पण रोग येऊ शकतात, लूज मोशन होऊ शकते, हे होऊ शकतं. तर डिसीज प्रोड्युसिंग microorganism should be free. So without referring to this list, just try to recall your memory. Please try to recall your memory and tell me one by one, everyone. Any four you may be asked in the exam for 2 marks, half marks each, as I have told you. So I will just slide this. I will change the slide and then you tell me. Chalo fatafat, start it. Start it. Chalo, what should be the qualities? One student, 4 qualities. Tell me one student will tell 4 qualities. Fatafat.
Yes, ma'am. May I, ma'am?
Yeah. Chalo.
Ma'am, it should be pleasant in taste.
Yes.
It should be the turbidity should not exceed 10 ppm. The total dissolved solid should less than 500 ppm. Yes, 500 ppm. And ma'am, it should be odorless.
Odorless, it should be perfectly cool. Colorless, it should have proper taste. It should have not have dissolved gases like H2S, SO2, etc. Then it should be free from microorganism. It should be free from poisonous impurities like lead, arsenic, etc. Will you be able to recall everyone? Shall I move further? Yes.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay. So we will start the next one. It is the purification of water. Just now I have explained the for screening suspended impurities, you have to use the sedimentation method and then coagulation. Sedimentation is you have to keep the water undisturbed. Here the sequence is little bit different. It is wrong. So don't follow this. Whatever I am explaining, please keep in mind that sedimentation is you have to keep the water undisturbed. It is floating impurities. To remove the floating impurities, sedimentation is done. You have to keep the water undisturbed for several hours so that the floating impurities will settle down because they are chargeless impurities, and then remove the water, supernatant water, and then it is made free from the impurities. That is sedimentation. Now second is coagulation, for which we have to use the alum. Please remember the formula of alum, real formula of alum, which is used as coagulant. Also remember its role, that is coagulant. Shortly it is written as Al2SO4 thrice, but actually what is the formula of alum? Turti. What is the formula of alum which we are commonly use in the rainy season? Remember the big formula, also the small formula. K2SO4, Al2SO4 thrice. So this is common there. Here also 24H2O. So this before that K2SO4, after that 24H2O. This Al2SO4 thrice is the generally represented as the alum, but correct formula is K2SO4 dot Al2SO4 thrice dot 24H2O. So it reacts with the water in presence of alkalinity of water. So these calcium and magnesium salts which are present in the water gives alkalinity. They increases the pH of water beyond 8. So this alum and these impurities are having charges on them. So it will remove the charges on them by precipitation. It forms the aluminum hydroxide. It is called as flocculant. This is called as coagulant. Remember these terms, coagulant. If the reaction is given, you will be asked, this is dash dash, this is dash dash. So this is the coagulant, alum, Al2SO4 thrice plus CaSCO3 twice. It is the charged impurity which is present, calcium bicarbonate. You will get twice AlOH thrice, that is alum hydroxide, aluminum hydroxide, which is a flocculant precipitate. It removes the charges on this and help to precipitate this chargeless impurities. Then along with it forms CaSO4 and CO2. CO2 is a gas which is removed, and CaSO4 again is a precipitate which is removed. So remember this reaction with the alum. Any form it may be asked in the form of what is the role of alum, what is LOH thrice stand for, what is its role. So it is a flocculant ppt and it helps to settle down the charged impurities after removing the charges on them. Charged impurity वरचा charge काढला की ते settle down करण्याकरता मदत करतं. Just learn this, then we will stop. I'll share the attendance link. I will take the attendance also manually. Learn the reaction. 1 1 2 3 6. 2 3 are 6. 1 1 2 3 are 6. Remember like this, so that it becomes easier. 1 1 2 3 are 6. 2 is AlOH thrice, 3 is CaSO4, 6 is CO2. CO2 escapes out. It is to remove the charges and to precipitate this charge after it has become chargeless. Alum hydroxide, which is called as flocculant. Double C it is. FLOCCULANT, flocculant. And this is coagulant. Alum real formula is K2SO4 dot Al2SO4 thrice dot 24H2O. Shortly it is shown as Al2SO4 thrice. Here CaSO3 twice, giving you 2 AlOH thrice plus 3 CaSO4 plus 6H2O. Are you through? Yes. Have you learned this reaction? Okay,
Yes, ma'am.
next lecture I'll ask. I'll give the attendance link. Today it was 6th lecture. Whatever I am telling you, please prepare everything. Please prepare everything. Nothing else extra will be asked in the examination. Whatever is not given in the PPT, that also is I'm explaining. Also, I'm correcting whatever is supposed to be there, correct information. I'll take manually also. One is present. Then 52 is present. 52.
Yes, ma'am. One is present, ma'am.
Yeah. Dikshit Sharma, what is your roll number? Dikshit Sharma. Dikshit Sharma, what is your roll number? Okay.
Ma'am, my roll number is 9.
9. Okay. Okay, then
Sorry, ma'am, my network issue. That's why I can't answer you at the time. It was
let it
late.
be next time be active. Then 4 is there present. Then 5 is there, 6 is there, 2 is absent, 3 is absent, 2 is absent, 3 is absent, 4, 5, 6 are there, 7 is
Ma'am, 3
present,
present है, ma'am.
10 is present. Yes, what happened? Arya, what are you saying?
मैम मैं रोल नंबर 3 हूँ मैम.
Roll number,
3.
are you present? 3.
Yes, ma'am.
Okay, 3 is there. Whatever I can see that I am writing. 62 is present, 32 is present. Sorry. एक minute. L division, na? 1 is present. Chalo, I will take from the beginning. 1 is present, 3 is present, 4 is present, 5 is present, 6 is present, 7 is present. After that, 10 is present. After 7, then 11 is present. 12
Ma'am,
is
after
present.
7, 9 is present.
9 also is present. Yes, Dikshit Sharma.
Yeah, ma'am.
9 is present. 13, are you there? 13 is present. Then
Yes.
present. Yes, I am writing from this participant list. 14 is present, 15 is present, 16 is present, 17 is present. 17 के बाद 18 is absent. 18 is absent. 19 is present. 19 is present. 20, 21 present. 20, 21 present. 22 present. 23 present. 23 present. Start preparing for the test. 24, and if you have any query, please ask me in the evening time, 4 to 6 and 9 to 10:30. In between, if you have any query, you just post me the message. Text message will be okay. 26 is there, 27 is there present, 28 is there, 29 is there, 30 is there, 31 is there, 32 is absent, 32 is absent.
Madam, 32 is present, ma'am.
Where? Who is there? 32. Okay. 32 present. 32 is present. 33 present. 34 present.
Ma'am, 25 is also present.
Huh?
Ma'am, you miss out 25.
No, I wrote it 25 present. Up till
Okay,
now,
ma'am.
2 and 18. 2 and 18 only absent up till now.
Okay, ma'am.
Yeah.
Okay.
So 32 is present, 33 is present, 34 is present, 35 is present, 36 is present, 37 is present, 38 is present, 39 is present, 40 is present. Up to 40, 2 and 18 are absent. 41 is present, 42 is present, 43 is present, 44 is present, 45 is present, 46 is present. Up to 46, 2 and 18 are absent. 49, 47 is present, 48 is present, 49 is there, 50 is there, 51 is there, 52 is absent. 51 के बाद, हाँ?
Present. 52 present.
Okay, here it is not seen. Okay, 53, are you there? 53, are you there? Yes, 53, are you there? 53 absent. 218, 53 absent. 54 is present, 55 is present, 56 is present, 57 is present, 58 is present, 59 is present, 60 is present, 61. 61, are you there? 61, are you there? So 2, 18, 53, 61. They are absent up till now.
Ma'am, 53 is present.
Why have you not given better attendance? Okay. 53 is present. Then 61 is absent. 62 is present. 63 present. 64 present. 65 present. After that, 66, 67 absent. 66, 67 absent. Absent. 68 present, 69 present, 70 present, 71 present. So absent number are 2, 18, 61, 66, 67. Correct? If you have filled the form, you may leave the class. If you have filled the form, you may leave the class. This week not possible, but next week one extra lecture I'll be taking, because next week we have to finish this lesson and we have to start the new one. So maybe 45 minutes lecture I need to finish this particular one lecture. Out of maybe X number of slide, we have finished 6 or 7. So maybe 45 minutes extra lecture I'll take. Saturday you are completely busy, na? Saturday, is there any scope? Yes, by the way, is the CR or BRR fixed for L division?
No,
Test,
ma'am, not yet.
test
ma'am,
will
not
be
yet.
there after completing the syllabus. So for completing this particular unit, I need 45 minutes extra lecture. Are you free Saturday, tomorrow, or any extra lecture? If I will try, if I'll wish to. CR BR झाले का तुमच्या डिव्हिजनचे?
नो मॅम, आतापर्यंत नाही झालेले.
मॅडमचा तर काल मेसेज आला होता, काल मीटिंग अरेंज केली होती की त्यांनी मॅडमने.
हो, इंटरव्ह्यू झालेत मॅम फक्त आतापर्यंत, पण डिसाईड नाही झालेले.
ओके ओके ओके, ठीक आहे. उद्याचा दिवस मी नाही घेते, सोमवारी बघूया आपण एक्स्ट्रा घ्यायचे, पण 45 मिनिट घ्यायचे, कारण त्याच्यानंतर टेस्ट ही कॉमन आहे, त्यामुळे माझ्या हातात नाही कधी घ्यायची, सगळ्या डिव्हिजनला कॉमन असणार आहे आणि ती संध्याकाळच्या वेळात असणार आहे, ज्या वेळेला तुम्ही फ्री असाल सगळेजण. त्यामुळे माझं फक्त काम आहे की सिलेबस कंप्लीट करायचं, त्याकरता 45 मिनिट्स. आणि नाहीतर मला एक फेवर करा की उरलेलं जे आहे ते सगळं हेच आहे, स्टरलायझेशन वगैरे वगैरे रिॲक्शन आहे. म्युनिसिपल वॉटर ट्रीटमेंट तुम्ही खूप वेळेला केलेलं आहे, 10वी 11वी 12वीला पण केले, तर तेवढं तुम्ही करा जर टेस्ट आधी आली तर. नाहीतर मी रेग्युलर लेक्चरला घेणारच आहे, जर एक्स्ट्रा लेक्चर घेता आलं नाही तर. गैरसमज करू नका, मी घेणारच आहे, पण टेस्टच्या आधी आले तर तुम्ही आता उद्या परवा जरा फ्री टाइम मध्ये तेवढा एक हे करा. मी ऑलरेडी पीपीटी शेअर केले. सगळेजण मेंबर झाले का? सगळेजण क्लासरूमचे मेंबर झाले का? हा हा, मी आज पाहणार आहे किती जण मेंबर झालेत ते. हा, करा पटकन. ओके, झालं असेल तर यू मे लिव्ह द क्लास, सबमिट द असाइनमेंट अँड लिव्ह द क्लास. Are you through? Om. Shall I end the meeting? Om. Om. Yes.